Hello everyone and welcome back to our channel. My name is Eric, I am an engineer here at Kemtrak. Today I am going to talk about how to detect leaks in your process. Imagine you own a brewery and you've just shipped out a new batch of beer from your latest recipe to restaurants and bars worldwide. Suddenly, you receive a call from a reseller. A customer has fallen ill after drinking your beer. It turns out the beer contained a highly toxic chemical. How could something like this happen? In industrial processes, heat exchangers are often used to control temperature by transferring heat between different process streams. However, leaks can lead to contaminations where one fluid mixes with another. A common heat transfer fluid in food and pharmaceutical processes is ethylene glycol. However, ethylene glycol is extremely toxic, and a leak can have devastating effects on both human health and your brand's reputation. Often, product contamination is only detected in the lab after the product has already left the facility, sometimes even after it has reached the customer. Monitoring ethylene glycol is challenging because it is a colorless liquid that cannot be measured directly. A commonly used technique is to mark the coolant with a dye and monitor traces of this marker in the steam condensate or product in real time. Suitable FDA-approved dyes for the coloring of food and drugs include brilliant blue and fluorescein. I am now going to demonstrate how a leak of ethylene glycol can be detected using a Kemtrak leak detector and a fluorescent dye. I filled a 2-liter beaker with water and inserted the fluorescent probe into it. I add a tiny drop of green fluorescent dye to simulate what happens in a heat exchanger where there is an ethylene glycol leak. The analyzer detects the leak at 10 ppm ethylene glycol almost immediately and could detect this drop in a volume that is 1,000 times bigger. Unfortunately, we see that some customers use bulk measurement techniques such as density or refractive index to detect leaks. If I were to use refractive index, I would need to add the whole content of my small beaker containing the fluorescent dye to get a signal. In this case, by the time you have detected the leak, it could already have killed someone. With this method, only catastrophic leaks of 1% ethylene glycol can be detected, telling you when it's already too late and the product has already been shipped. By contrast, leaks can be detected with remarkable sensitivity down to 0.1 parts per billion using a Kemtrak leak detector. To put that into perspective, that's 100 million times more sensitive than traditional bulk measurement techniques such as refractive index. This is like comparing the size of a small house to the size of the sun, in terms of diameter. By continuously monitoring the product for any signs of ethylene glycol contamination, Kemtrak photometers help protect your brand, minimize product loss, and reduce costs by identifying leaks at their source. So which technique are you going to buy if you can get an analyzer that is 100 million times more sensitive to leaks for the same price point? If you found this video informative, give it a thumbs up and subscribe to our channel. Until next time, happy analyzing! Kemtrak's here to guide the way, catching leaks before they stray. Ethylene glycol you can't hide, with Kemtrak we're by your side.